Hey everybody, welcome to Unit 9, conic sections. This is the last unit of our pre-calculus course, so let's get right into it. We're talking about circles and parabolas today, the first two conic sections. Circles we've actually talked about back in geometry, so some of this might look familiar to you. We have the equation of a circle, which is r squared equals x minus h squared plus y minus k squared, where r is our radius and our center will be at hk. Remember, those are the opposite signs. Okay, so first we have a problem that asks us to write the equation of a circle. Right, we have the point -3 is on the circle with center -1, 2. Now what's kind of cool is that they give us a point which would actually match up with h and x and y, and then they give us the center, which would match up with h and k. So really, we're plugging in and solving for r. That'll give us the radius, and then we can start filling in the center that we know. So we're going to use this formula and start plugging in. This would be our x and y. This would be our h and our k. Okay, so all I've done is plugged in my x, my y, my h, and my k into the formula. Then I'm going to do the square root of both sides to get r all by itself. Okay, I'm going to do some of this pretty quickly. Right, -3, this becomes +1, that's -2. We want to square that, that gives us 4. -3 minus 2 is -5, we square that, and we get 25. All under the radical. 4 and 25, it's going to give us 29. Okay, now we're going to plug this in for r. We're going to plug in our center, h and k. Remember, we're going to change those signs when we write it. And then if we square radical, you're going to see that that goes away. Right? So 29 under the radical, we have to square it. We want x minus -1, so it'll be plus. That's why the signs change. And then y minus k, which is 2. These go away. So really, our final answer for this (29 equal to). Okay, so really, it's not anything different than what we've done before. Back in geometry, where they would give us the actual radius. Here we had to find what the radius was, and then we plugged into the equation. Nothing to it. Okay, so here's a problem for you to try. Pause the video and resume when you're ready to check your solution. Alright, let's see how you did on this one. I'm going to label x and y and my h and k. Now the formula is not here, but it's pretty easy to remember. Radius is going to equal square root of x minus h squared plus y minus k squared. Excuse me. Let's see, 1 minus 4 is -3 squared would give us 9. -2 minus 2 is -4 minus 2, I'm sorry, -4 squared rather is 16. 16 and 9 is 25, and that gives us 5 for our radius. So we're going to plug in 5 for r. We already know our h and our k, and we leave x and y alone. So let's see. That would be 5 squared, x minus 4 squared, y minus 2. Let's see, that 5 squared becomes a 25, and the rest of this stays how it is. So your final answer, 25 is equal to x minus 4 squared plus y minus 2 squared. All right. Next, we're going to sketch a circle. These problems a little bit different than what we did back in geometry, because back then we didn't have to use any special tricks like completing the square. Right? What they give us for an equation, I see x squareds and y squareds. I'm thinking about maybe grouping things together and using completing the square so that we get that parentheses squared look that we want. You'll see what I'm talking about when we start doing this out. Okay, so what I'm going to do first of all, I'm going to move this 16 away from everything else by subtracting it. And then I'm going to group together my x's. So let's see, x squared minus 8x plus y squared minus 6y, and that's going to equal negative 16 now. Okay, then we're going to do completing the square on this. Why? Because we'll get a perfect square trinomial, which we can write as x plus or minus something squared, which is what we want for this particular formula. So let's do completing the square. I take my b term divided by 2, square it, that's negative 4, squared would be 16. Let's hold on to that for a second. We're also going to need to do completing the square here. So negative 6 divided by 2, that's really negative 3, squared, which is 9. So we will be using these things right now at the same time. Right? We did completing the square here. I've got to add this 16 in here, but I also have to keep it balanced, so I'm going to have to add it on over here as well. So that becomes x squared minus 8x plus 16. I'm going to do the same thing with this 9. I'm going to add it here and over here. So y squared minus 6y plus 9. I had the negative 16. I now have to account for these that I just added in. Okay, now we can write this shortened. Right? This would become x minus 4 squared plus y minus 3 squared. My negative 16 and my positive 16 is going to cancel out. I still have 9 left over. Alright, so we've actually got exactly what we need. And we did a little bit of completing the square to get there, but that's stuff that we've been doing pretty much all semester. Our radius, we take the square root. So the square root of 9 would be 3. And our center, we change the signs on h, so that becomes positive 4 and positive 3 for k. Now we can start plotting. Right? 4, 3 is our center. Our radius is 3, so we go out 3 in every direction from our center. And then we connect. Alright. You're up. Try this one out. Pause the video, resume it when you're ready to check. Let's check this one out. So if you remember, we're going to want to get rid of that 9 right away and then start grouping our x's and our y's together. And right away we're in pretty good shape. As long as we can start completing the square, we'll be able to get those trinomials that we want. So this is my b term. for x, my b term for y, and that's what we're going to be adding in to x and y, and then both added in on this side. So let's see. Okay, so I've added in both sides to 9 and both sides to 1. This is now going to reduce to x plus 3 squared plus y minus 1, right? That's our term there. And then the negative 9 and positive 9 cancel out, and we're left with 1 on this side. This is going to be a smaller circle, right? Take the square root. That will give us 1 for r. Our center is going to be the opposite, so negative 3 and positive 1. So let's see in our graph over here, negative 3, positive 1. And our radius is 1, so we go out 1 in each direction from our center and draw in our circle. Not bad. Alright. We can also find x and y intercepts of a circle. To find any y-intercept, we want to plug in x at 0, and for any x-intercept, we're going to plug in y at 0. Yes, I realize I said that upside down from what I wrote it. Don't worry about that. So, they ask us to find the intercepts of a circle, so we're just going to do exactly this. But we have to do it twice, right? We got to do it for x and for y. Plugging in 0. So, let's find our x-intercepts first. So, let's see. That would mean that we have x plus 2 squared. If I plug in 0, that's negative 1 squared equals 25. Negative 1 squared is just plain old 1. We'll subtract that from both sides. Now we can start solving for x a little bit more clearly here. Right, we've got x plus 2 remaining. This is going to be plus or minus the square root of 24. Don't forget about that plus or minus thing. And then we'll subtract 2. So, here's how I'm going to write it for x. The x-intercepts are going to be negative 2 plus or minus the square root of 24. Now we've got y. So let's see, if I plug in 0, that would leave us with 2 squared plus y minus 1 squared equaling 25. If I square this, we get 4. We'll get rid of the 4 by subtraction. Take the square root. That becomes a plus or minus. So y minus 1 equals plus or minus the square root of 21. And then we'll add 1 to both sides. And this is how we'll write it for y. 1 plus or minus the square root of 21. Those are our x and y intercepts. Really not that bad, right? Just plug in 0 for one, you get the other by solving. Okay, so I want you to try this one out. You know the drill. Pause the video and resume it when you're ready to check your solution. Alright. For x, just going to plug in 0 here. That's going to leave us with 1 squared can't do anything with this x minus 2 yet. 1 squared, that's just 1. We'll get rid of it from both sides with some subtraction. Now we take the square root. Remember to affix that plus or minus. And then we'll add 2. So how we'll write this out will be 2, right, positive, plus or minus the square root of 15. We've got to do the same thing for y. If I plug in 0, that's going to give us negative 2 squared. Negative 2 squared is 4. Oops, plus. We'll subtract 4 from both sides. So let's see, y plus 1 squared equals 12. Take the square root. We got that plus or minus thing happening again. And we'll subtract 1 from both sides. So we have negative 1 plus or minus the square root of 12. And I believe that's it for circles. But if you remember, this lesson had 2 parts to it. Parabolas is up next. Alright. Parabolas. You've seen them since Algebra 1. This is going to be the weirdest looking parabolas that we've talked about so far. Because if you remember too, we've actually talked about them back in Unit 2 of this course. And we had a completely different definition for them back then too. So let's look at it in terms of conic sections. Okay, a parabola is the set of all points x, y in a plane that are equidistant from a fixed line called a directrix, something we've never talked about before, and a fixed point not on the line called the focus. The midpoint between the directrix and the focus is the vertex, something that we can remember from the past. And the line that runs through the focus and the vertex would be our axis. Okay, so looking at it graphically, this is the parabola itself. You have a focus, which is a point, a directrix, and the distance from the focus to the parabola itself should be equal to the distance from the directrix to the parabola too. Okay, so those distances are equal. And then we know already that from the axis we have symmetry, which is good to know. Then they give us this little extra thing here, P. P is going to come up in some of the equations that we're going to see in a moment. Okay, but this is just what we're dealing with visually. We have the standard form equations for a parabola with vertex HK. So we're still working with that HK, and you're going to notice that we're going to have to change the signs on them pretty much the whole time while we're working with them. Okay, but we're going to actually talk about having parabolas that are the U's, or the upside down U's, that we're used to seeing, which will be a vertical axis. But then, because we're actually working with y squared, which we've never really done before, and x squared at the same time, that allows us to start looking at graphs that are going to end up having to fail the vertical line test, right? So we'll actually see some pretty cool things like this, which is also why we've been able to look at circles as well, because they're in a second dimension altogether, which is kind of cool. So we have a horizontal axis, which will allow us to see some different looking parabolas than ever before. Okay, but the formulas for them very similar. The big difference here is that for vertical we have x and x minus h on one side, and then for horizontal we have y minus k on that side. The 4p is always the same, and whichever side is on the left, I guess we could say it, without the 4p, that's going to be the squared side. The directrix is going to have the equation y equals k minus p, or for horizontal, x equals h minus p. So we're going to want to figure out which one of these we're working with at some point before we can really fill in the equation itself. Plus we have p, which is going to be equal to the focus minus the vertex. So got a lot of stuff to work with. I would write these down and you can refer to them whenever you need to throughout these problems. Alright, first problem asks us to find the standard form of the parabola with a vertex 2, 1 and a focus of 2, 5. So first of all, let's see what we're dealing with here. Quick sketch, right? We have 2, 1 as our vertex and 2, 5 as our focus. So I already know that if this is my vertex, it's going to end up going up like this around that focus. So I know the general direction. Now P is going to be the distance between those. So I take my focus and I subtract my vertex. And I know that I'm using the 5 and the 1 because if I use the 2's, I'm not going anywhere. Those are my x's. I know that the difference here would be between my y's. So we know that the distance here for P is 4. And we could have really counted that too if we wanted to. But this is more meant to see what's going on. Because now I also know that I have an axis that's vertical. So vertical axis means that we're using x minus h on the squared side. Our h term here matches up with our vertex. 2, so it would be x minus 2 because we use the opposite sign. 4 times p, which we found to be 4, times y minus k, which is 1. And then I just have to figure out what that becomes, really simplify it. And there's your standard form of that particular parabola. Okay, so we found P, we figured out that we need to use the vertical formula, and then we plugged everything in. We're going to do one more, okay, before you try one on your own. This one says that we have the standard, to find the standard form of the parabola with vertex -1, -2, and focus 3, -2. Alright, some things that we should probably do right away this time. Let's label our vertex with h and k. Let's take a quick look at what this looks like. Let's see, -1, -2. Then we have 3, -2. This is our vertex, that's our focus, so it's going like this. Our p-value is the distance in y. So I take my focus and I subtract my vertex. 3 minus -1, that gives us 4 for p. Plus, we can see that we have a horizontal axis. That means we want y minus the vertex coordinate, k. That would be opposite sign, right? Negative or minus -2. Change that sign. 4 times p, which is 4, and then x minus -1, so that becomes +1. So here it is. Y plus 2 squared equals 16 times x plus 1. That is the equation of this particular parabola. So I have one for you to try out. See how you do. Pause the video and resume it to check. Alright. Did you label HK right away? I would have. Alright, we're going to figure out what this thing looks like. I'm going to do a quick sketch. I'm not going to actually count them out on here. They give us 10, 5, which would be somewhere up here, and they give us 10, 3, which would not be quite as high up. But that's my vertex, and that's my focus. So I can see my parabola is going like this, giving us a vertical axis. Right, now I didn't draw it really quick, so I can't just count. I have to actually solve for P. But that's okay, because I know that's going to be a difference in my y's here. So I take my focus, I subtract my vertex, and we end up with P equaling -2, which is fine because we're going to have a negative sign, which will really be the reason why this is flipping upside down when we look at our equation. But we know that we have a vertical axis. That means we want x minus h first. That's going to be squared. 4 times p, which is -2. And then we have y minus k, which is -5. So here it is. Your solution. I hope that you got that, because they're really not that difficult of problems to start out with, right? You just find out which formula you need to use by taking a quick look at the sketch and solving for P, which is not that difficult either. These problems look a little challenging to begin with, but you're going to see that they're not really much different either. Okay, we want to find the focus of the parabola. They give us x equals -1/2 y squared plus 3y minus 1/2. Alright, fractions. Yeah, everybody hates fractions, right? Not Mr. Marchetti. I know what to do with them. Right, what I'm going to do is I'm going to multiply everything in this problem by -2. Why would I do that? Because that's going to give me y squared all by itself, which is what I want. So that'll be -2x. If I multiply by -2, that gives me positive y squared, times -2 gives us -6y, and times -2 gives us +1. Okay, so now this is looking a little more user-friendly. No more fractions, no big deal. Alright, now we want to start thinking about, this is not quite the form that we want it, right? We want this to be parentheses y plus or minus something squared. So we've got to use completing the square. I'm going to take my b term, which is -6, divide it by 2. That would be -3 squared, which is 9. So I'm going to add 9 inside and add 1 here. Now, I can't just add the 9 here. I have to keep everything balanced. So I'm going to add 9 over here as well. But I'm also going to get rid of this pesky 1 at the same time, because I don't really need it over there anymore. So let's see. That means that we have 9 minus 1 is 8 minus 2x. And then we're going to simplify this into y minus 3 squared. That was the whole completing the square step. And then it's looking pretty good, except that I don't like the way that this looks. I want a p-value in front and then parentheses x minus something. So here's what I'm going to pull out. I'm going to pull out a -2, because that's going to give me positive x and -4 on this side. And then we got y minus 3 all squared. Alright, so let's see. If I have the y minus 3 as my squared, that means that we have a horizontal axis. So the only thing we need now is P, and then we can figure out the rest of the stuff pretty easily. Right? We know that 4P is equal to -2. If we divide by 4, we get -1/2. So that's our p-value. Why do we need that? Because if we know the vertex, which is 4, 3, we know that the focus is going to be, because it's vertical, it's going to be a change in x. I'm sorry, horizontal rather. It's going to be a change in x. So we need to just combine our p-value with x, and that'll give us our focus. So let's see, 4 minus 1/2, that would be 3.5, and we're not doing anything to that 3. So this is our focus. So quick recap. Don't like fractions? Multiply everything by -2. Right? We complete the square, get rid of the thing that we don't need, that -1, and make sure that we add that completing the square term, oops, sorry, that's up here, to both sides. We use completing the square, we factored out so that it's now in the correct form. We figured out which way this thing is looking. That helped us determine what to add P to. Right? We figured out what P was, we added it to the correct coordinate. Alright, here's one for you to try. Pause the video, resume it when you're ready to check your answer. Alright, let's try this one out. By the way, I'm pretty sure this is the last one for this lesson, so let's see how you did. We got to multiply by +4 on everything on both sides to get rid of that quarter. So that's going to give us 4y equals x squared plus 8x plus 8. We don't want the 8 here anymore though, so we'll subtract that away. And then we're going to do completing the square on that 8. So here it is, 8 divided by 2 squared, which is really 4 squared. So we're going to be adding 16 to both sides here. Alright, so let's see. 16 minus 8, that would be +8. Completing the square tells us that this all reduces to x plus 4 squared. Alright, so I got my x plus 4 with a square. I know it's going to be vertical, and I'm going to factor out a 4 from each of these. So we get 4 plus 2. I'm sorry, 4 times y plus 2 equals x plus 4 squared. And it's vertical. This is our center, H, K. We've got to change the signs on those. So we already know our vertex. It's -4 and -2. We want our p-value, and we know that 4p equals 4. So p is 1. Because this is vertical, that means there's going to be a change in y, and it's a change of +1. So our focus will be at -4, and -2 plus 1 is -1. Did you get that for your focus? I hope you did, because you just went through a 34-minute video to get to this point, the finish line. We're all done with circles and parabolas. Yeah, there was a lot of work going on there, but really it's just a whole bunch of earlier pre-calculus tricks. So completing the square happened a whole bunch, and just putting stuff into equations. Keep the equations with you nearby. When you're doing all these problems, you'll do fine. Alright, see you next time when we talk about ellipses. Ooh.